Hey everyone, I hope you all are safe and doing good. So in the series of learning C++ programming language, we are discussing vectors in C++, right? So till now we have discussed like what is STL, because vectors are part of STL standard template library. What are vectors, how to declare a vector, how to initialize it, how to access vector elements, how to modify vector elements, right? Now there are basic things we have discussed about vectors, but there are more member functions that we can use on vectors, and these functions, these methods are extremely useful when you are using vectors, right? So you should know about these functions or these member functions, right? Why I'm calling this like member functions? Because vector is a class, I have told you, and whatever vector we create, that acts as an object of that class, right? So those member function of that vector class we will be using one by one in this video, right? Okay, now let's create a file first, new file, vector functions.cpp, right? So first obviously we will include IOStream, that header. Then if you use vectors, then you have to include vector, right? And then namespace. First let's create a vector, right? And suppose vector is integer and I'm just taking v, right? So first thing we'll be discussing is iterators. So first let me just tell you what is an iterator. It's like a pointer, but it's not exactly a pointer. You know what is a pointer? It is a variable that contains address of another variable, right? Okay. Now iterator is also like pointer, but not exactly same. Iterator and pointers are different, right? But we can say like an iterator is used to point the memory address of STL container classes. We know vector is a class. I told you like it's a sequence container and it is a class. So iterator is like many other sequence container classes also, like list, map and many more. So vector is used to point the memory address of these container classes, right? And using vector we can access, what we can do, basically we can access the elements of those container and we can perform some operation on those elements, right? Like it's like a pointer. Like in my class, if suppose I'm pointing to someone using this finger, like, so this is what a pointer. So using this pointer, this is like an iterator, we can say. I can call that student like come here, rather than calling his or her name or roll number, just pointing. So it's like a pointer, or I can access that student with this pointer only, right? I hope you are getting my point. So same iterator. Right, so using iterator we can access elements, okay, of that container class, like vector or list or map, like this, right? Now see, and exactly see, I don't remember like all the member functions on vectors, but there is a site and you also don't need to remember all the things, right? One by one we'll be using, you just learn and remember the frequently used member function, right? And whenever you use in your program again and again, these things would be in your mind. I think you don't need to put extra efforts to learn these things. You just use these things in your program, practice, right? So there's a website like C++.com and there. And there is a website like C++.com and here you will get vector. So here you will get all the functions, member functions of vector, C member functions, right? First are iterators. So here we have these functions, begin and rbegin, rend, cbegin, cend, and like this. So we'll be discussing 2 or 3 functions and these you will practice. Remaining functions you will practice, right? So first we'll be using begin and end. See, as you know, whenever you click on this function, there is a proper description of this function, begin. It is going to return the iterator to the beginning. Return an iterator pointing to the first element in the vector, right? Same end, it will point not to the last element. Let me show you what is end. See, this function returns an iterator referring to the past the end element in the vector container, not the last element. No. See, what is this past the end? This element is theoretical element that would follow the last element in the vector, right? So after last element, and practically if we see there is no last element, no element after the last element. So basically it does not point to any element, right? Now what does this mean? How to use this begin and end? Let me just show you. So suppose this is a vector and I want to print this vector, right, using iterator. So first you have to, declare an iterator. How to declare? You have to write same like vector and whatever the object type of this vector, int, right, an int type of iterator we want, scope resolution operator, and you have to use proper here iterator, this, and after that name of the iterator, x, y, z, a, b, c, any name you can take. I am taking here it, right? Now this is the iterator it. Okay, now with for loop what we can do, we are not taking any normal variable to access to print these elements like we have done in previous lectures, but we will use iterator. So we just call on this iterator it is equal to, now first we want to point this iterator to the beginning of this vector, the first element. So which function you will call on this vector? Begin. V dot begin, right? So this function is going to return the iterator to the first element. So now this it is pointing to 1. Then it, this iterator not equal to the end. Till then we are going to print the elements, right? So v dot end, and then we just do plus plus or plus plus it or it plus plus, iterator plus plus, right? And simply we are going to print these numbers. Now we have a dereferencing operator, because it's like a pointer. So if you want to dereference a pointer, then we use this. This is a dereferencing operator, star asterisk it. So this is how we can access using iterator all the elements, right? It's like pointer, no? Right? So with pointer also, if you want to access, because in it we have like some address. So at this address, what is the value? Using asterisk operator we can access that value. So that is why this thing, right? Now, and if you run this, then okay, there is this error, this is extra token here, right? And in vector also we have this thing. So save this and now let's run this. See, 1 2 3 4 0 78. Now why, what is we can use only simple variable also, like int I is equal to 0, I should be less than whatever the size, right? But here you don't need to remember or the size of this vector. You just increase, you just put some more variable and that's it. You don't need to change the size here, right? So directly the iterator would move from here to here. See, now this time this value you will get. So you don't need to remember or take care of the size of the vector. And you can also do something like this. We can modify this, like if I write plus 1 here. So I want to start from 2. So this also we can do, and let's run this. See, from 2 it will print 2, 3, 4 like this, right? And there are many more ways here we can use this begin and end. We'll be discussing in later videos when we are writing more and more programs on vectors, right? This is just a simple example just to tell you, yeah, this is how we can use begin and end, right? So it is pointing to the first element and this will point this element. After the end, the last element is 9. So whatever after this last element, it will point here, but practically there is no element. So it is not pointing to any particular element. So we cannot dereference this end. Now next are this rbegin, rend, means it return the reverse iterator to reverse beginning. right, and rend. So what does this mean? If I use here reverse iterator, suppose, let's just copy paste this thing here, and let's comment out this thing, because this is, so these are for begin and end, and this thing next whatever we'll be discussing here, that is for rbegin and rend. So to create a reverse iterator, you have to write here reverse iterator, right, and the iterator name, it or any other iterator name also you can take, I, abc, xyz, anything. So let's take rit, reverse iterator. Okay, now rit, this iterator, on this we cannot call this begin function because it is reverse iterator, so you have to call rbegin, right, and this rit not equal to rend, till then rit plus plus, and while dereferencing you have to use rit. So what you think, what it will print? See, this rbegin, it will return a reverse iterator pointing to the last element in the vector. Last element, it will point to the last element, means it is like reverse beginning. So if you want to print that vector in reverse order, we can just use this thing, and whenever you increase this iterator rbegin, then it will iterate backward, right, towards the beginning. And rend means, see, rend will point to, see this rend, it returns a reverse iterator pointing to, to the theoretical element preceding the first element in the vector. So that is rend. Before the first element, practically obviously there is no element, but theoretically we consider that there is an element before the first element. So rend will point to that element, right? So we are moving in reverse order, right? So this will print this rbegin, this will point where? Here, to this element 9, and whenever we increase this rit plus plus, then it will move backward like this, right? And this rend will point to one element before this first element, before 1, but practically there is no element, so it will point to no element. So we cannot dereference this thing. So it will print what? That vector in reverse order, right? Okay, sorry. Let me just run this again and see. It will print, it is printing in reverse order that vector, right? Same, we have some more function like c begin, c end for constant. So those things you will try. Okay. So next is this capacity. We have discussed like size and capacity, these two member function, but let's discuss more things. Size, maximum size, and capacity. These things let's discuss. Size, it will return the actual size of that vector, how many elements in that vector right now. Maximum size, maximum number of elements that vector can contain, can hold, it will return that thing, right? And capacity means it will return the size of allocated storage capacity for that vector. How size and capacity are different, let me just show you with an example. So for this I am creating another vector. Let's suppose I am taking a vector of type char. Okay, we have A, E, I, O, these 4 vowels here, right? So let's print size, max size, and capacity. Size of this vector is, we have a function size that we directly call on this vector, right? Same for max size, we have a function max size, and for capacity we have a member function capacity. So like this we are printing. Okay, now let's run this and see what's happening here. Size is 4. Okay, let's just decorate a little bit. After everything we have a new line operator. So here size is 4, maximum number of elements this vector can hold, these number of elements, and capacity is also right now 4. So both size and capacity are same, 4 and 4, because initially we have initialized only 4 elements. Now what we do, let's insert one more element here in this vector. So we can use pushback function, right? it is going to push element in the last of this vector, right? So what I want to push back, IOU, right? Now let's just again print all the three things. So after pushing back one vowel U, I'm just printing again size, max size and capacity. So first 4, this is the capacity and this is the maximum size. After inserting, size is actually 5, max size would be same, but capacity is now 8. See the difference, size and capacity, because it is going to double its size, right? So first 4 was the size, capacity was 4. Now if you insert one more element, so it is going to double its size. So 1, 2, 3, 4, it becomes 8. Right now capacity is 8. Right now the capacity of this vector is 8. It can store 8 elements, and actual size is 5. Maximum size is, I have told you. Now why this capacity is going to be doubled? Because to avoid the reallocation of this vector again and again after each insertion. What we'll do here, if I'm inserting this U now, so what it will do internally, another vector would be created of capacity 8, and all these values would be copied in that vector, and this vector is to be destroyed, dumped, right? So rather than reallocating again and again after each insertion, right, now capacity is 8. So till 8, I mean after U we can insert 5 more elements here, and there would be no reallocation of these elements, right? But after 8, if you insert 9 elements, then the capacity would become again double, means 16, right? Okay. So this is the thing, size, max size and capacity. Now if you want to resize, for that also we have a thing like resize. If you want to change the size of the vector, then also we can change. But here in this case, what will happen? Let me just show you. So now the size of this vector is what? Actually 5. So I want to resize it. So how to resize? Vowels dot, just call this resize, and how many number of element? The size would be to store how many elements? So here you have to give that n value. So that would be 3. Right? So right now in this vector we have A, E, I, O, U. After resize, if you print this vector, let me just show you what it will print. So what it will print after resize, till 0 to size of that vector, and we are using at function to access the elements right now, right? So see, it is going to print A, E, I, only 3 elements, because we have resized the vector to 3. So resizing means this is like n, the number of element you want to store in that vector, the resize. So after n number of elements, if there are extra elements in that vector right now, so it is going to erase all that elements, remove all those elements and destroy those elements. Because in vector we have 5 elements after inserting this U, after push back this U. But after resizing, it will print only 3 elements, A, E, I, removing all the 2 elements, right? So yeah, it is going to alter the vector elements also, this resize, this operation, this function, right? And if the vector is here integer, let's take integer vector here, int. Now I want to resize this vector, resize 10. I have resized this vector to 10. So see, let's see what it will print. See, 1, 2, 3, 4, 5, 0, 0, 0, 0, 0. Because it is integer, so it would be, the remaining element would be initialized to 0, because you are not providing any value. Right now vector size is 5, but you have resized to 10. Now it will insert 10 element here. So 5 are there. By default it will insert 0, 0, 0. Right? And see here, right now the capacity of this vector is also 5. But you have to resize, you have resized this to 10. So if you want to print here the capacity of this vector, size and capacity, let's print both size and capacity of this vector after resizing. See, size is 10, capacity is also 10. right? Here we have empty, reserve, shrink to fit. Empty means you have to test whether the vector is empty or not. Reserve means request a change in capacity. If you want to like reserve a seat, if you are sitting somewhere in a classroom, right, and you have reserved a seat next to you, and if someone is coming, you will say that my friend is coming, so this seat is reserved. Right now there is no one on that seat, it's no element, but someone is going to come in future, you know that thing, so you have reserved that thing. So capacity is of 2 seats, but right now only one element, only you are sitting there. So if you want to reserve extra capacity, if you want to request a change in capacity, we can use this reserve function. See, request that the vector capacity be at least enough to contain n elements, right? N means any number of elements, you can say. Okay, let's see how to use this empty and reserve. So see, the capacity was 10 and after resize, size was also 10. But if you want to reserve the capacity to 100, so what we can do, like I know I'll be inserting 100 elements in this program later. So rather than reallocating again and again after the insertion, for capacity, because capacity is going to double, right, after if that is capacity is exhausted. So at first I'm going to reserve 100 capacity for 100 elements. So here if you want to reserve, then we can call this reserve, and here 100 for 100 elements I want to reserve. So right now capacity would be 100 if you run this thing. See, let me show you. See, capacity is 100 and size is 10, right? So you can reserve extra capacity also, space also. And what was empty? Before printing this vector, if you want to check like the vector is empty or not, so we can use that thing also. Like if this vector v dot empty, we can call this function. Then we simply print no element in vector. So it will return, if the vector is empty, it will return true. So if true, there is no element. But right now we have elements in this vector, so it is going to print those elements, right? Okay, let's run this again. See, it is going to print these elements, right? But if the vector is empty, suppose there is nothing, don't resize it, right? Now let's run this. See, no element in vector v, size is 0, capacity is 100, because vector is empty, size is 0, and capacity we have reserved 100 for 100 element, and no element in the vector. So this is how you can test using empty. Shrink to fit means if you want to shrink the capacity of that vector equal to the size of that vector, then we can call that shrink to fit function. And see, in resize we can give like the resize 10 and I want to insert 50 here. So it will insert 10, 50 in this vector, right? So this thing also we can do in resize, like 50, 50, 50, right? 10 times 50, right? Number of times, and then the value you can give. That is also fine in resize. Or only resize, only size you give 10, then the element would be by default initialized to 0, 0, 0, 0. Right? 10 element, 10, 0 in that vector. Okay, now shrink to fit is what? So it requests the container to reduce its capacity to fit its size. Please go through this website and you will get here everything, right? You don't need to remember everything, and even I don't remember everything, every function and the description and how to use that function, right? So how to use this thing? See, right now size is 10 of this vector because we have resized this vector, and reserve the capacity is 100, right? But now I know that I don't want to insert 100 elements, so I want to shrink its capacity to the actual size. So what we can do here, after printing this capacity, if you want to shrink, then you can call that function in this vector v, on this vector v dot shrink to fit. And now after this, if you print again the capacity, after shrink to fit, the capacity is, okay, whatever the capacity, it is going to print. See, first the capacity was 100, size was 10, but capacity of V after shrink to fit is 10. We are requesting to shrink its capacity to the actual size. So 10 and 10, right? Okay, this is what we can do. But it is not necessary that this request would be granted shrink to fit. It depends. Okay. Next are how to access the elements. This thing we have discussed in previous video using this operator, then add, front, back, and like this. Now next is modifier. We have some modifier. Pushback we have discussed. Add element at the end. Pop back means it will delete the last element, right? Insert. So let's see these two, pushback and pop back first. So this is our vector V and there is nothing in this vector. So now I am going to push back some elements in this vector, right? So it is going to add the element at the last of that vector and it is going to increase the obviously the size of that vector by 1 by 1 by 1, right? One element we can add using this thing. So let's use do while loop here. Okay, here it will ask like enter element and we are taking a value, suppose val. So let's take into val a variable first, right? And then this thing we are going to push back in this vector, this variable, push back and val, right? And if you enter 0 then exit. This is the condition we'll put here, right? And in this while loop we just put val. If the val is 0, exit, right? Okay. Now pop back. Pop back means it remove the last element and it will decrease the container size by 1, right? So let's pop back here also, v dot pop back, and that's it. Last element it will pop back. Again pop back, 2 pop backs suppose I'm using, and we are now printing the element of this vector. This is how we are going to print after pop back. Okay, let's run this and see what output you are getting. Now enter element 1, 2, 3, 4 and now 0. Now vector elements after pop back is only 1, 2, 3 because we have used 2 pop back. So 1, 2, 3, 4, 0. 0 was last element, 0 was pop back, 4 was popped back, and remaining elements are 1, 2, 3 only, right? So this is how we can use. Before popping back, you can just, if you want to print, if you want to check the number of elements, we can check. It's before pop back. So now it will print 2 times. 1, 2, 3, 4, 5, 0. Vector elements before pop back 1, 2, 3, 4, 5, 0. After pop back 1, 2, 3, 4. 2 elements 0 and 5 are out and destroyed. Container size was decreased by 2. Right. Now next is we have insert. Okay. This function is also useful. So if you want to insert some elements at a particular position, so you can give, like, obviously you have to point to that position. Iterator we will use to point. How many number of elements you want to insert, that thing you need to give, and what element you want to insert, that thing you need to give. 3 things, right? And it will insert, see, the new elements before the element at the specified position. Whatever position you will give that using that iterator, before that position those elements, new elements would be inserted, right? And definitely to increase the container size by the number of elements inserted, right? So let's see how you are going to use this. Now we have some vector, like I have a vector v and these are the values in this vector. Okay, now I want to insert values here at position 3, right? So now you have to give what value you want to insert, how many value you want to insert, and the position. So position, I mean to point to this thing, we use iterator obviously. So let's create an iterator. We know there is a thing in STL iterator. So let's use that thing, iterator, and Suppose IT, I'm taking the name of that iterator, and IT, I'm initializing this IT to point where IT is equal to v dot begin. Let's suppose first begin. So first it will point to this here, begin, right? So whatever value will insert, if I call this v dot insert and pass the iterator, the position, the location, IT, how many value you want to insert? Suppose 2, and the value is suppose 80. And now let's print the vector elements. So let's run this and see what output you will get here. Vector element after insertion 80, 80. See, the position was beginning. So before the position inserted 2, 80 and 80, right? If you want to insert at some more specific position like at third, so begin plus 3, so 2. So this is begin plus 2 means 1 and 2. At third position 280 would be inserted, right? Or if you don't want to insert 2, only 1, that is also fine. Let's run this. See, only 180 at third position, right? And these elements would be reallocated, right? Shifting to like towards the right one position. So all the elements are reallocated. So definitely it's not an efficient method to insert element in vectors. But in list we can insert an element at specific position more efficiently, right? This is more tedious because of this reallocation of all the elements after that position, right? So this is how we can use insert. Or you can insert like maybe 1080s, 580s, 1080s, or 1000 time any element, right? So see, 1080s. This is what insert. At specific position if you want to insert, then you can insert. More erase, clear. We can use clear means it will destroy all the elements of this vector, right? So how to call v dot clear? Fine. If you want to clear, this all the elements of this vector, you can use v dot clear, and it will erase all the elements, destroy all the elements. And after that, if you print vector elements after calling clear, let's run this and see what output you will get here. So after insertion, these are the elements. After clear, there are no elements because size is 0, and if you print size, that would be 0. If you want to erase particular element, if you want to remove any particular element and any particular position, you can use erase. See, we have erase. This is clear, this is erase. So it is going to remove from the vector either a single element or a range of element. First and last, the range you can give. First element would be included in that range, means first element would be removed, but last element is not in that range. Last element would not be removed, right? Let me show you one example of this erase. In this vector, now if I apply v dot erase, if I call this function, then first the position you need to give, and that we can give using iterator, because iterators are obviously pointing to used to point the elements in that container class. So either you can create an iterator like this, right? Or directly we can use like v dot begin. This element I want to remove this 5. So this is from begin to 1, 2, 3 plus 3. So after erasing one element, which element would be erased? From beginning 1, 2, 3, this 5. So let's run this. What output you will get here? There would be no 5 here. And if you want to give a range, like more than one element I want to erase, so we can give a range also. Suppose from beginning to v dot begin plus 3 or begin plus 2. These elements I want to erase. I don't want to erase any particular thing. So begin means from 1 to begin plus 2, 1 and 2. So this is the last iterator position, but this 4 is not included. So only 1 and 2 would be deleted. 4, 5, 6, 0, 98. That should be the output. Let's run this and see. 4 5 6 0 98, right? This also we can do like plus 1 from 2 to 5. These thing I want to erase 2 4 5. So begin plus 1 first would be erased and last would be 6 because 6 is not included. So we begin plus, from 2 it would start. So how many you will add? I want to relate 2 4 5. So this is for your assignment. Now pause the video and write down this function, erase function, what you will write here. So plus 1 2 1 2 3 plus 3. Plus 3 means right now iterator is here 6, but 6 is not included. So only 2 4 5 would be erased. 1 6 0 8 should be the output. So 1 5 6 0 8. Let me just see. Begin plus 1. Now here is the iterator plus, okay, it's begin plus 3. So from here 1 2 3 it should be begin plus 4, right? Now 2 4 5 would be erased. 1 6 0 8, right? So this is how we can use erase. The remaining function are like swap and more function are also there, so you can use those functions too, right? Just try out those functions. If you're not getting, you can let me know in comment section. We can just discuss the remaining function in next video, right? So I think vectors are clear. So now I'll see you in the next video. Bye bye. Take care.